So factoring the top, I'm going to get an x and an x, and it's going to be minus 4 and minus 1. And I was about to rewrite the bottom, because that's what we normally do if you can't factor, although I noticed something. I noticed that if I write 1 minus x, nothing would cancel because nothing's identical. But I might put a note up at the top here, just something to remember, that if you have x minus 1 and 1 minus x, do you remember that you could always factor out a negative? And that sure might be helpful in this example. Because my non-permissible value is going to be, whether you change the bottom or not, I hope you can see that x can't equal 1. That was what would cause you to divide by 0. But if I factor out the negative, this would cancel because they're exactly the same. If I don't factor out the negative, I run into a problem I can't cancel. So we do have to notice this. Whenever you have the same factor, but one is like x minus 1 and the other is 1 minus x, or if you had x minus 3 and one was 3 minus x, you can factor out that negative to make them the same. And that's going to be important because with that little algebra nuance, we do have a whole. And to figure out the whole, then I'm going to write my new equation. I'm going to write my new equation in green, and I'm going to take my time with it. All I'd be left with is an x minus 4 on the top, and I'm left with a negative on the bottom, which I don't think you can write this. This looks funny. Do you agree I have to put a 1 there? A negative left on the bottom, but I would like you to change this. If you divide this all by a negative, you see that the x would be negative, and the minus 4 would become positive. And this is important. I like this one because this is y equals mx plus b. You know that. This one is a little bit trickier to graph. But it's a straight line. And if we want to find the whole, we find the whole, well, it's going to be at 1 comma something. But now when I plug in 1 into my new graph, I'm going to get 3. Negative 1 plus 4 is going to be 3. Do we have to do steps 3, 4, and 5? No, because we're graphing this green equation. It's a line. You know how to graph lines. So you just go. You know that you have a y-intercept at 4. It's not, I think it's a good idea to always draw as many intercepts. And you see that when you plug in 0 for y, x would equal 4. You have a slope that is going down, but we need to, at 1 comma 3, draw an open circle for our hole. So when a graph has a hole, you graph the new equation and add the hole. If the new equation is just a straight line, you don't have to do steps 3, 4, and 5. Well, I guess you still are doing your intercepts and some nice points. But you don't have to worry about horizontal asymptotes or oblique asymptotes because your new equation is just a straight line. It never has an oblique asymptote. It never has a horizontal asymptote. It's just a straight line. So we draw the straight line and add the hole. Questions for practice on this one are just number 3.